Let's solve the differential equation y double prime plus 4y prime plus 4y equals 0. This is a case of repeated roots in the characteristic equation. First, we form the characteristic equation, r squared plus 4r plus 4 equals 0. Notice that this factors as r plus 2 squared equals 0, giving us a repeated root r equals negative 2. Therefore, our first solution is y1 of t equals e to the negative 2t. Since we have a repeated root, we need to find a second linearly independent solution. We'll use D'Alembert's method of reduction of order. We assume a solution of the form y equals v of t times y1 of t, which is v of t times e to the negative 2t. The first derivative is versus prime times e to the negative 2t minus 2v times e to the negative 2t. The second derivative is versus double prime times e to the negative 2t minus 4v prime times e to the negative 2t plus 4v times e to the negative 2t. Now we substitute these expressions back into the original differential equation. After substitution and collecting like terms, most terms cancel out, leaving us with v double prime equals 0. We integrate twice. The first integration gives versus prime equals c1, and the second gives versus equals c1t plus c2. Therefore, the general solution is y equals c1t e to the negative 2t plus c2e to the negative 2t. Our fundamental set of solutions is e to the negative 2t and te to the negative 2t. Let's verify these are linearly independent by computing the Wronskian. The Wronskian determinant is e to the negative 4t, which is never 0, confirming linear independence. Let's plot some typical solutions with different initial conditions to see the behavior.